Today I am going to discuss about wind power plant. Wind energy is the use of wind to provide the mechanical power through wind turbines to turn electrical generators. Wind turns the propeller blades of a turbine around a rotor which spins a generator that generates electricity. Wind power generation means getting the electrical energy by converting wind energy into rotating energy of the blades and converting that rotating energy into electrical energy by the generators. Coming to the basic components of windmill, the first one, that is blades, rotor, pitch, braking mechanism, low speed shaft, gearbox, generator, controller, anemometer, wind vanes, nacelle, high speed shaft, yaw drive, yaw motor, tower. The blades are made of fiberglass. Generally the most wind turbine are either 2 or 3 blades based upon the application. Some of the places they are used for monoblade system, 2 blade system and then 3 blade system. These blades are attached to the hub to the rotor mechanism. Rotor includes the blades and hub together. Rotor provides the pitch regulation for power output optimization. Pitch turns blade out of the wind to control the rotor speed, that is too high or too low to produce electricity. This is the braking mechanism. The brake is a disc type. It is used to stop the rotor in emergencies. That is, suppose if there is no load, at the time wind is available maximum, during the period, with the help of braking mechanism, stop the rotor blades. By using this technology, lifetime is increased and also the maintenance is reduced. Low speed shaft. Generally rotor turns the low speed about 15 to 30 rpm. With the help of 15 to 30 rpm, we can't generate the output AC electricity. Generally we need to generate the power. The minimum required is 1000 to 1500 rpm. The next is gearbox. The gearbox connects the low speed shaft to the high speed shaft and increases the rotational speed 15 to 30 rpm to 1000 to 1800 rpm. In low speed shaft, the speed is 15 to 30 rpm. The gearbox is linked between low speed shaft as well as for high speed shaft. After the gearbox, the speed is considered for 1000 to 1800 rpm. This mechanism it will be taken with the help of the gearbox. Generator. Generally in the windmill, the generator used induction generator that provides 50 cycle AC electricity. Generally the wind output is AC, that is the frequency is 50 Hz. Controller is used to control the turbine. Suppose wind speed is above 55 miles per hour turbine and damage at the time automatically stopped with the help of controller. Normally wind speed is about 8 to 16 miles per hour. The maximum, the withstand capacity is less than 55 miles per hour. With the help of controller, it will be sense the speed. With the help of anemometer, it will be controlled. Suppose if the speed is maximum, automatically with the help of controller, the wind system is shut down. Anemometer. Here the anemometer is used to measure wind speed and transmit the data to the controller. Based upon the speed, it will be receive the signal and control this operation. Generally, the voltage we can measure with the help of voltmeter. The current can be measured with the help of ammeter. The power we can measure with the help of anemometer. Similarly, the wind speed can be measured with the help of anemometer. Wind vane is measure wind direction and communicate to the yaw drive. Generally, this is the horizontal axis windmill. The windmill are classified for 2 types. Based upon the position of shaft, it is classified for 2 types. One is for horizontal axis windmill, another one is for vertical axis windmill. This is horizontal axis windmill. It is rotating only 180 degree direction. Based on the wind vane, it will be measured the wind speed direction. It will be sense the yaw drive. Based upon the yaw drive, yaw motor is operated. Which direction the wind is there, based on the direction the wind blades are rotating. Nacelle is end cover for the machinery that translate wind power into electric power. High speed shaft, already we have discussed, it drives the generator at a speed of 1000 to 1800 rpm, but practically we are getting 1350 to 1550 or 1600 rpm. Yaw drive rotates the rotor facing towards the wind directions change. Based upon the wind vane, the signal is given to the yaw drive. This yaw drive, with the help of yaw motor, the position is changed. Yaw motor powers the yaw drive to rotate the yaw drive with the help of yaw motor. Tower made from tubular steel, concrete or steel lattice, supporting the complete the wind structure. Because the wind speed increases, the height is also increased. These are the various the basic component used in the windmill, that is blades, rotor, pitch, low speed shaft, gearbox, generator, controller, anemometer, wind vane, nacelle, high speed shaft, braking mechanism, yaw drive, yaw motor and then tower. This all the basic component is presented both horizontal axis windmill as well as for vertical axis windmill. The only the difference is the shaft position is changed. Coming to the next topic, the wind turbine are classified for two types based upon the shaft position. One is horizontal axis windmill, another one is vertical axis windmill. Now you can see here horizontal axis windmill. Here the shaft position is placed in horizontal. For that purpose, the name is represented for horizontal axis windmill. Generally, the wind caused by pressure gradients, wind converted into kinetic energy. That kinetic energy is converted into mechanical energy. Further, that mechanical energy is converted into electrical energy. The kinetic energy in the windmill, that is half rho A V cube. A is nothing but area, rho is density of air, and V is the wind velocity. That is kinetic energy of rho A V cube. The blades of the turbine, generally the blade is single blade system, two blade and three blade system, but most of the places they are preferred either two blade or three blade system. The blades of the turbine are attached to hub. It is mounted on a turning shaft, goes through a gearbox, where the turning shaft the speed is increased. The gearbox is attached with low speed shaft, that is main shaft, as well as for high speed shaft, which runs a generator to make electrical energy. Energy generated is converted to utility grid or energy storage to provide DC battery, that is connected externally via AC to DC converter. Here, this is the horizontal axis windmill. The structure is tall. For that purpose, the tower is placed. The wind blades are rotating only 180 degree direction, that is particular only for single direction. Based upon the nacelle, the speed is which direction is available. Based on the direction, it will be rotating with the help of yaw motor and then yaw drive. In horizontal axis windmill, yaw control is required to rotate based on the wind direction. In horizontal axis windmill, the power generation is also maximum, that is more amount of power is generated. The main drawback is either horizontal axis windmill or vertical axis windmill. Impact of wind turbine on wildlife, mostly in birds and bats. Generally, the wind blades, it hits the birds, it is affected the blades, the wind blade. The sharp is like a helicopter blade. And one more thing, sound and visual impact are two main public health and community concern associated with operating wind turbine. Here the main thing, the blade is available, that is either two blade system or three blade system, that is attached to the hub. It is mounting on the rotor and then the gearbox. Here the wind blade is rotating slowly, in that the main shaft, otherwise the low speed shaft, the speed is available 15 to 30 rpm. With the help of 15 to 30 rpm, we can't generate the electricity. Again, they are placed in the gearbox. Based upon the wind is rotating either minimum or maximum, it will be adjusted. The output with the help of high speed shaft, this 15 to 30 rpm is carried from 1000 to 1800 rpm. Again, here the kinetic energy is converted into mechanical energy. With the help of alternator or AC generator, that mechanical energy is converted into electric energy, after that given into the grid. Here the braking mechanism is used. Suppose if there is no load, the wind speed is available maximum, at the time the rotating is the more. With the help of the braking mechanism, it can be observed whenever the load is not available, the rotating mechanism is stopped. At that time the lifetime is increased, the maintenance is also reduced. This is horizontal axis windmill. Coming to the vertical axis windmill, here in vertical axis windmill it is rotating for 360 degree direction. Here the shaft is placed on the vertical direction. For that purpose the name is represented for vertical axis windmill. Here the n number of type of blade is there. That is here 4 blade system, 5 blade system, 6 and then 8 blade system. Here also the gearbox is there. Low speed shaft, high speed shaft, generator. The same mechanism, but the main difference, it is similar to the horizontal axis windmill, but the shaft position is for vertical, and vertical axis windmill the structure is short, but in horizontal axis windmill the structure is tall. This is the structure is short. It can constructed at any places. This is we can place for any of the places we can generate the power because the structure is short. And vertical axis windmill rotating 360 degree direction, that is all direction it is rotating either left or rightward also. The power generation is also low. This is the main, it is similar. The only thing is nothing but the shaft position is vertical. For that purpose it is represent for vertical axis windmill. And one more thing, here the power generation is less. It can be rotating for 360 degree direction. No need for nacelle, no need for yaw control, no need for yaw drive. The next one, selection of site for installing windmill. That is either horizontal axis windmill or vertical axis windmill. The main thing, exclude conservation land, that is away from the agriculture land, away from the human being, away from the industries, schools, so on, etc. Selected area within 5 miles of road, that is it should be constructed nearer to the transport facilities such as road and then railways. At the time of installation, the huge heavy equipment is required. We need to transport with the help of highways or railways. For that purpose, the transportation facility is required. The selected area within 10 miles of transmission line, that is close to suitable electrical grid. It is constructed away from the transmission line. Again the line losses is available. For that purpose, as much as possible it should be constructed near to load center. Connection with national power grid. Once we have generated the power, immediately we can connect it into the grid system. And annual average wind speed we want to measure initially. Suppose the wind power plant, the initial cost is very high comparing to the remaining other power plants. If we are not measuring annual average wind speed, after that the total cost is minimized. And one more thing, the per unit cost is less. Suppose the average annual wind speed is maximum, we are generating the maximum amount of power. At that time the per unit cost is also minimized. And the significant tourism infrastructure places, it should be attracted for tourist places. For the particular places we can erect or constructed for the windmill. And land use is primarily for grazing and cropping. These are the various, the primary selection of site for windmill. The first one is it should be constructed nearer to the roadways, and another one we want to measure for annual average wind speed. And next one, for the particular places the land is exclude conservation land, and it should be constructed nearer to the national power grid, and it should be attracted for tourism infrastructure places. These are the various selection of site for windmill. And the comparison between horizontal axis windmill and vertical axis windmill, already you have seen. In horizontal axis windmill, it is the structure is tall. Vertical axis windmill, the structure is short. This will be placed only particular few places, but the vertical axis windmill we can construct it the wherever is required. For the particular place we can construct the vertical axis windmill. In horizontal axis windmill, starting wind speed is high, that is greater than 3 meter per second. In vertical axis windmill, the starting wind speed is less, that is 1 meter per second. In horizontal axis windmill, noise is 50 to 60 decibels. In vertical axis windmill, noise is up to 10 decibels. In horizontal axis windmill, failure rate is maximum. In vertical axis windmill, failure rate is minimum. In horizontal axis windmill, the maintenance is complicated. In vertical axis windmill, the maintenance is convenient because here the structure is tall, short. And horizontal axis windmill, rotating speed is high. In vertical axis windmill, the rotating speed is low. In horizontal axis windmill, effect on boards is greater, but in vertical axis windmill, effect of board is lower. That is, here the structure is short, the board hitting is very less comparing to the horizontal axis windmill. The wind direction is performance dependent on direction, that is only 180 degree direction. Wind direction performs in any direction, that is 360 degree direction. In horizontal axis windmill, fan speed high, that is greater than 1000 rpm. In vertical axis windmill, fan speed is low, that is less than 1000 rpm. In horizontal axis windmill, rotor spin around horizontal axis, that is the rotor is placed on horizontal direction. In vertical axis windmill, rotor spins around vertical direction, that is the rotor is placed on, the shaft is placed on vertical. Next, the advantages of windmill. That is no pollution, it is eco-friendly, low prices, renewable sources comparing to the geothermal, tidal and solar. In windmills, the lowest price renewable sources, that is the per unit cost is very less. Do not produce atmospheric emission, it is not releases for carbon dioxide, nitrous, H2S, so on etc. Wind is available abundance everywhere in the world. We can generate it at any places. We can generate it with the help of wind power. That is the main advantage. Suitable for domestic application, that is small and remote domestic applications. That is villages in remote area. We can supply electricity with the help of windmill. Wind farms can be attracted tourist places. Cost of generation power is cheap. That is the per unit cost is very less comparing to the remaining renewable energy sources. Coming to the disadvantages of windmill. Good wind sites are often located in remote locations, that is far away from the cities and far away from the town. For that purpose, the transmission losses is increased and the transmission line cost is increased. That is the drawback. Sometimes board have killed by flying into the rotor. That is the major drawback. Whenever the board is hit on the wind blades, the some amount of the bend is available automatically. The RPM, that is, it is reduced. Wind energy cannot be stored. Generally, the wind is available in a day maximum 8 to 12 hours. The remaining time, the wind is there. That much of the power generation capacity wind is not available. For that purpose, we need to kept for battery, the backup purpose. The remaining time, supply the power. It makes a lot of noise. That is visual and noise pollution. It needs big open space of land. The large amount of the land is required. Wind does not always blow. In a day complete 24 hours the wind is not blowing, and in a year 365 days the wind is also not blowing. The wind is available in a day 24 hours, but the power generation capacity that much of available the wind is in a day 8 to 12 hours, or some of the places 12 to 14 or 16 hours is available. That remaining time we can't generate the power. The generation of power is not constant. It depends on various factors like wind velocity and direction and duration. These are the various drawbacks of windmill. And applications of windmill is used for generating electricity, water pumping, that is agriculture purpose, telecommunication, weather station, street lighting and hybrid power generation. In this section we are studied about what is the wind power plant and what are the various components in windmill, how the windmills are classified. That is, one is for horizontal axis windmill, another one is vertical axis windmill, and where we can select the wind power plant, that is selection of site for windmill, and comparison between horizontal axis wind turbine as well as vertical axis wind turbine. Next we have discussed advantages, disadvantages and applications of windmill. That's all. Thank you.